Okay, so we're supposed to find x. We have this big right triangle. Um, so I could see two right triangles actually. There's one here, and then there's the bigger one. So we'll want to keep that in mind that we could always split it up into two different triangles. Ba, 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 ba. So we can, yeah, we can find this small piece, and maybe that'll help us find x. Okay, because I think if we take that small piece and plus x, we could add that and maybe use the Pythagorean theorem some way to help us find this. And using this number to help us find x. Okay, so anyway, let's find that small piece. Couldn't hurt, and it could help. Um, so looking from angle 56, from the degree of 56, we have what's opposite of it, and we don't have this hypotenuse in our smaller triangle. Okay, so if we did sine, that would be the opposite side of 115 divided by the hypotenuse side, which we don't know, so we'll call that x. That's actually not going to help us with that goal here, though, okay? So let's consider, maybe we'll use sine in the end, but let's consider the other possibilities. We also have cosine in our tool belt, and cosine would be not the opposite, not the hypotenuse, so the adjacent would be, oh, that's one thing we wanted, right? And actually, let's not call that x, because we already have an x. Let's call this y. Cosine is the one that's going to help us the most. Oh, actually, no, sorry, cosine won't help us the most either because the cosine involves the one we want to use, but we also don't know the hypotenuse. So there's two unknowns there, and we can't solve that equation. Okay, so let's try our last option, tangent. Tangent of 56 is always what's opposite, which is 115. That's good. That's a number we know, so we want to involve as many known numbers as we can. And then we divide that by the adjacent. So if this is the opposite of this smaller triangle, and if this is the hypotenuse, then y is our adjacent. That's the one we want to use because this one is something that if we solve it will actually help us. It's finding that y value that we said we wanted in the first place. Okay, this one could help a little bit because it would find the hypotenuse, and then we could use the Pythagorean theorem to get the value we're looking for, but this one's going to be the quickest. So to figure that out, let's do tangent of 56 in our calculator. I'll just take some decimals. And then I'm trying to get y by itself. So I can't when it's in the bottom of a fraction. So let's multiply both sides by y. Right? That cancels it out on the right. We've got y on the left. And then to finish getting y by itself, I've got to do the opposite of multiplying 1.486, blah, 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 all that stuff. Okay, so I've got to divide that from both sides. So when I do that, I've got 115 divided by that big long decimal. So 77.57. So that's our y value. Okay, so we've solved a little bit about the triangle. We still haven't figured out what x is, but hopefully we're getting closer. X is a part of this bigger right triangle. I mean, we could say that x is also a part of this triangle over here, but that triangle doesn't have any right angles. We couldn't use sine, cosine, or tangent directly to do that. So let's consider the big triangle, and I'll highlight that, what I'm talking about here, in bigger font. That's not big enough. Okay, so we're talking about this bigger triangle. We have one side of it. This side's 115, and we don't quite have the other side, but maybe we could use sine, cosine, or tangent to help us find it. And with this bigger triangle, we have this angle of 35, okay? And that angle of 35, that corresponds with 115, so we have what's opposite, and we'd like to know the adjacent side, right? Because in this bigger triangle, in the purple one I just drew, this is the hypotenuse. So we've got 35, we've got its opposite, and we want to know the adjacent, then we could finish making an equation for that. Okay, so that's tangent again. If we're talking about the opposite over the adjacent, let me keep the colors consistent here. Okay, because this is the, knowing why I'm doing this is the most important part. The calculation part gets easy after time. So with the big triangle, 35 degrees is down here. And if I can figure out what this side is, then I could subtract 77.57 from that length, and I'm left over with x, which is what I want. Okay. So in order to find this big side, it's adjacent to 35, right? Because this has to be the hypotenuse because of the right angle down here. And this is what's opposite, so this side is the adjacent. So I want to use opposite over adjacent, so I want to use tangent for this problem. So tangent of 35 equals what's opposite, the 115, divide by this whole adjacent side, which I'm just going to call A right now. This entire side over here is A, the big side. Same process as before. I'll do tangent 35 in my calculator. I'll just use 0.7, that looks easiest. Trying to get A by itself, so let's multiply A to both sides. Then we need to divide 0.7 from both sides, because that's multiplying right now. So if you divide 115 by 0.7, you get 164.29 when we round to the nearest decimal. Okay, so that's the big side down here. That must mean that x, here look, if you take that little side length y plus that side length x, those add up to be the bigger side we just found of 164.29. And now we can get x by itself just by subtracting 77.57 from both sides. So x is whatever that result is. So roughly 86.72. There we go. We found x.